Series and parallel combination of capacitor. A series combination. In series combination, the magnitude of charge on all plate is same. Now from figure A, V equals to V1 plus V2 equals to Q by C1 plus Q by C2. Equation 1. From figure B, V equals to Q by C. Equation 2. From 1 and 2, Q by C equals to Q by C1 plus Q by C2. This implies 1 by C equals to 1 by C1 plus 1 by C2, or C equals to C1 into C2 by C1 plus C2. This is the formula for equivalent capacitance of a capacitor in parallel. If there are n capacitor in series, then 1 by C equals to 1 by C1 plus 1 by C2 plus dash dash 1 by Cn. Now if all capacitors are of same capacitance, that is C1 equals to C2 equals to C3 dash Cn equals to C dash say, then 1 by C equals to 1 by C1 C dash plus 1 by C dash plus dash 1 by C dash nth term equals to n into 1 by C dash equals to n by C dash. Hence C equals to C dash by n. Thus equivalent capacitance becomes 1 by n times of individual capacitance. Again, as C equals to Q by V, this implies V equals to Q by C. This implies V proportional to 1 by C, as Q is same for all capacitors in series. Hence V1 by V2 equals to C2 by C1. This implies V1 by V2 plus 1 equals to C2 by C1 plus 1. This implies V1 plus V2 by V2 equals to C2 plus C1 by C1. This implies V2 equals to C1 by C1 plus C2 into V1 plus V2, or V2 equals to under bracket C1 by C1 plus C2 into V. Similarly, we can calculate V1 equals to C2 by C1 plus C2 into V. Question: in the circuit shown in figure, find A, the equivalent capacitance, B, the charge stored in each capacitor, C, the potential difference across each capacitor. A, C equals to C1 into C2, because capacitors are in series, so equivalent capacitance C equals to C1 into C2 by C1 plus C2 equals to 5 by 6 by 5 microfarad. B, the charge stored in each capacitor is Q equals to CV equals to 1.2 into 10 to the power minus 4 coulomb. C, in series combination V proportional to 1 by C. Hence V1 by V2 equals to C2 by C1. This implies V1 equals to C2 by C1 plus C2 into V. This implies V1 equals to 60 volt. Hence V2 equals to V minus V1. 100 minus 60 equals to 40 volt. Parallel combination. In such type of combination, one plate of capacitor is connected together and other plate of capacitors are connected to the other end. The parallel combination is equivalent to a single capacitor with the same total charge Q equals to Q1 plus Q2 and potential difference V. Thus Q equals to Q1 plus Q2. Question 1. From figure 1, Q1 equal to VC1 and Q2 equals to VC2. From figure 2, Q equals to VC. Question 4. Using 2, 3 and 4 in equation 1, we have VC equals to VC1 plus VC2, or C equals to C1 plus C2. This is the parallel combination equivalent capacitance and is equal to the sum of individual capacitances. If there are n capacitors in parallel, then equivalent capacitance C equals to C1 plus C2 plus dash Cn. If all the capacitors are of equal capacitances, that is C1 equal to C2 equal to C3 equals to dash 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 Cn equal to C dash C, then C equals to C dash plus C dash plus C dash 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 C dash n term, or C equals to n into C dash. This equivalent capacitance is equal to the n times of individual capacitances. Now, since Q equals to CV or Q proportional to C, since V is same for all capacitors in parallel combination. Hence, Q1 by Q2 equals to C1 by C2, or Q1 plus Q2 by Q2 equals to C1 plus C2 by C2. This implies Q2 equals to C2 by C1 plus C2 into Q1 plus Q2, or Q2 equals to C2 by C1 plus C2 into Q. Similarly, we can calculate Q1 equals to C1 by C1 plus C2 into Q.